Hello everyone and welcome to We Are Learners. The topic that we'll be considering today is linear equations in two variables. So this is how our roadmap is structured. Fine people. We'll see the introduction part. That means we'll be defining what do we understand by linear equation in one variable or two variable, right? I'll be covering linear equation in one variable as well, although I'll be, throwing a light on it. And then we'll try to cover solutions of linear equations in two variables. We'll be defining what do we understand by solutions and then the two methods that is according to the latest curriculum, right? Substitution method and elimination method. In case if somebody is interested in cross multiplication method, which is the deleted portion, then definitely you can comment and I'll be doing the needful. I'll prepare a video and then I'll upload. Anyways, I'll come up with cross multiplication method as well, but I need your valuable insights. In case if you need that, then definitely you can communicate the same to me and I'll be preparing it. Fine people. So let us get this started. Introduction part states that see the entire definition is being bifurcated into different segments. So I'll be quickly going through with the definition first, and then we'll have this on one node and we'll try to have an exploration based on the situations. All right. So a simple linear equation is a statement of equality between two algebraic expressions. It involves an unknown quantity, which is a variable, and the power of the variable should always be 1. And we have two sides, LHS and RHS. So let us consider this. Let us move to one node. I hope my one node is visible. All right, let us consider a case. Suppose we have x plus 5 and it should be equated to 7. Now this is an equation. This is how I represent an equation, right? X is the alone variable. So it is actually an equation in one variable. Why it is an equation? Because we have an equals to sign in between. Also, people, this is an algebraic expression. So according to pointer number 1, all right, any expression that can be equated to another expression or constant or an algebraic term, right? A constant can also be treated as an algebraic term. So people, this is the basic of an equation and it is known as linear because the power of this variable is 1. So we have covered all the pointers. Now suppose if we have an observer and that observer is right over this equals to sign. So this will be the left hand side of the observer and this will be the right hand side of the observer. Fine. Similarly, we can have x plus y equals, let us say 8. This is also an equation, but this equation is actually an equation in two variables. We have x and y. Now we usually call this as x and y as variables because they are having the capacity to change their values, right? Suppose for one question you are solving the value of, you're solving it for the values of x and y and it come out to be 1 and 2. For other question it may come out to be different, right? It may not be 1 and 2. So that means they are having the capability to change their values. So that is why they are termed as variables. This is just a short story on variables. Why do we use variables as such? Fine. Now let us move back to our slide and then we'll see what slide is stating. All right, standard form I'll discuss when I'll be using the next course. Fine. Solutions of linear equation in two variable. What do we understand by this? Let us go back to our one node. Fine. I hope my one node is visible. Now suppose if we are given with an equation like this, 2x plus 3y equals 5. Usually standard form is like this, ax plus by plus c equals 0. Now, in order to convert something in this form, although this particular equation is not in this form, so how do we convert this? We need to shift this RHS to LHS, right? So whenever we are performing a transposition, we will be changing the sign. So plus 5 will become negative 5. Now this is the standard form. It is at par with this particular form. So if somebody is asking you what is the coefficient of x here, so it is a, which is 2. Coefficient of y, which is b, that is 3. And constant term comes out to be minus 5. This is the basic. Solution means what? Suppose x plus 5 equals 7. This is linear equation in one variable. You need to find the value of x for which LHS and RHS, they come out to be equal. So either you go with hit and trial method or you directly use transposing method. That means this plus 5 is to be shifted to RHS. So when you shift this to RHS, it will become negative. So 7 minus 5 is what? 2. That means the value of x comes out to be 2. All right. Now we'll be having only this particular value for which this equation holds true. That means this is the only value for which x, this LHS and RHS becomes equal. Otherwise, they do not. We do not actually have anything as such for which you can, make this statement hold true for other values as well, right? So whenever we have a case in which linear equation one variable is given to us, we always have unique solution. I told you I'll be throwing light on linear equation in one variable. While linear equation in two variable, let's consider this as a case. I'll be calling this as equation number 2. If you substitute x as 0 and y as 2 in this, LHS and RHS becomes equal. If you substitute x as 1 and y as 1 again in this, LHS equals RHS. If you substitute x as 2 and y as 0, again LHS and RHS will become equal. You can also define x as 1.5, y as 0.5, right? So we can have infinitely many solutions in linear equation two variables. All right. And these are the points. Why these are known as solutions? Because these points are satisfying this equation. And if you see graphically, all right. So if we represent these points, so this is how the line will look like. All right. So whatever we points have on this line, whatever we have as a points, right, or multiple points on this line, they are the solution of this equation. Right? And we can have infinitely many solutions. As you can see that we are calling this as a line, and line is endless. It is extending in both the directions. Fine. So we can have multiple points. That is why solution to linear equation in two variable is infinite. Then your question, you can ask one question, sir, then why we are calculating solution using elimination method and substitution method? What significance will it make? Now suppose if we have an equation like, if we have a line like this L1 and we have another line like this L2. So they are intersecting at a particular point. Now people tell me something, if this is the point which is on L1, it should also be on L2. So we are interested in this particular part. So that is why we use elimination and substitution method. We get only one value of x and one value of y for which this particular pair of lines are intersecting. So we are interested in their point of intersection. That is why we call this particular set as solution. Fine. But if we have suppose coincident lines, right? So they are one over the other. That means we have multiple points, people. And if we have multiple points, that means solutions are many. Then according to the methods that we'll be discussing in next few minutes, we will be calculating only one particular set for x and y for which this comes out to be true. We will not be calculating multiple values, right? So I'll tell you why we are not calculating multiple values in next part of this. So we can have coinciding lines. Here the solutions are many. Here we will be having only unique solution in linear equation two variables, right? Which is the point of intersection. We can have a situation where the lines are parallel. Let us call this as L dash and this is M dash. They are parallel, that means they are not intersecting, and if they are not intersecting, that means no solution is such that we can have here. Fine, people. So how do we judge this? See, this case and this case, they are known to be consistent because they are having one solution. This is inconsistent. It is having no solution. So let us move back to our slides and let us see what we have in our slides. Solution part is done. Okay. Substitution method. Which is the very first method, and it is very basic method that we can have here. X plus y equals 6 and x minus y equals 4 is given to us. We'll be solving it using substitution method. So let us move back to our OneNote. X plus y. Okay, just allow me a second. X plus y is 6 and x minus y is 4. I hope my screen is visible, people. This is equation number 1 and this is equation number 2. We need to solve it using substitution method. how can we solve this using substitution method? What we do, we see, this is the algorithm. We first take any one of the equation and we express one variable in terms of another variable. Now, as this y, this is y, this is on LHS, it is actually with plus. So if you shift it to RHS, it will become negative. You call this as equation number 3. Now from first equation, we have calculated the value of x. We will not be putting it in first equation. If you put it in first equation, then you will get a situation like this. That means 6 equals 6. So this is not something that we want, right? So we call this as absurd results. So from where you are calculating the value of one variable, you're expressing one variable in terms of another, just substitute whatever you got in the next equation, right? So if I'll put the value of x in this equation, then it will become 6 minus y equals 4. So it will be 6 minus 2y equals 4. Once you shift this plus 6 to other side, transposing 4 minus 6, it will be minus 2, minus 2y, minus and minus will go away. We have y as 1. So once we get the value of y or any variable, right, substitute it in any of the equations. So as I can see third, right? So we can substitute it here. So it will be 6 minus 1. The value of y is 1. So it comes out to be 5. How do you represent a solution? This is the solution. X is 5 and y is 1. How do you represent it? We usually write it in ordered pair, x comma y, where x can be written first and y is to be followed. So x is 5 and y is 1. This is how we represent the solution. Now, how to check whether this is the solution or not? 5 comma 1. You substitute it in equation 1 and equation 2. You will get LHS equals RHS. So if you substitute it in 1, it will be 5 plus 1, which is 6. 6 equals 6, true. Second is 5 minus 1 equals 4. 4 equals 4, true. So this is how substitution method works. Right? We calculate the value of one variable and then we substitute it in another variable. Sorry, another equation, not variable. Now let us move to our slides. Elimination method, which is the last method that we'll be discussing here. After this, in case if you are interested, you can let me know in the comment section and do subscribe the channel if you are new to the channel. All right, we need to consider these equations. 2x minus y equals minus 1. All right, and another equation is 3x plus 2y equals 9. You can keep this noted because after this we'll be moving to whiteboard. I hope my whiteboard is visible. Yeah. So the equation was 2x minus y equals minus 1. I'll be calling this as equation number 1. And 3x plus 2y equals 9. I'll be calling this as equation number 2. We need to solve this now, right? Using elimination method. Now in elimination method, people, the purpose of elimination is to eliminate one variable so that it will become linear equation in one variable, and then it is very easy for us to solve, right? Linear equation in one variable can be solved very easily. How we can have this analyzed and which variable is to be eliminated? See, people, if I'll talk about elimination, suppose if plus 2 is given to us and we need to eliminate this, then definitely I should be subtracting 2 from it. Then this will become 0. If suppose minus 2 is given to us, if I need to eliminate this, then definitely plus 2 can be added. This becomes 0, right? So this is a brief on what we are going to use in elimination. Now, people, if you observe equation number 1 carefully, if I multiply equation 1 with 2, it will become 4x minus 2y equals minus 2. I'll be calling this as equation number 3. Why I have multiplied it with 2? Because here, if I see the coefficient of y is 2 in equation number 2, while the coefficient of y here is minus 1. I need to see, somehow I need to do some manipulations so that either I can add the equations and get the variable eliminated, or I can subtract the equations or get the variables eliminated. But that will only be possible if the coefficients are same. So I just need to ensure that coefficient of any one variable should be same. So that is why I did this. Now I'll be rewriting equation number 2 below it. Now people see, if you add equation 3 and equation 2, then this will go away because one is positive and other one is negative. You are adding them, so this will be 7x equals Obviously, it is plus 9 and minus 2 differences to be taken, and the sign of greater number in magnitude will be followed. So it will be 7. So from this, we can get the value of x as 1. Substitute this value in this equation, you'll get the value of y. So let us consider this here itself. So it will be 2 into 1 minus y equals minus 1, minus y equals minus 1 minus 2. So this will be minus y equals minus 3. That means value of y comes out to be 3. So the solution comes out to be 1, 3 according to x, y ordered pair. Fine. Now if we want to check whether this is the correct solution or not, just put these points on this line. So it will be 2 into 1 minus 3 equals minus 1. 2 minus 3 is minus 1. Yes, correct. It is getting satisfied. What about the second equation? 3 into 1 plus 2 into 3 equals 9. RHS is 9. So this will be 3 plus 6 equals 9. 9 equals 9. Yes, it is also getting satisfied. That means both the points are the solution for both the equations. That means they are intersecting, and they are intersecting at 1, 3. We'll also be checking the condition before we actually start with elimination or cross multiplication method, right? Using standard form of linear equation in two variables, which is ax plus by plus c equals 0. All right. So suppose if two equations are given to us, a1x plus b1y plus c1 equals 0. All right. a2x plus b2y plus c2 equals 0. Then using this, you can calculate the value. You can actually, conclude whether we are getting one solution or the lines are parallel or not. So how you can get this? Okay, let us consider this as well. Suppose if a1 upon a2 does not equals b1 upon b2, then in this case you will get a unique solution. That means lines are intersecting, and we call this as consistent. If a1 upon a2 equals b1 upon b2, all right, and it should also be equals to, okay, it is b2, c1 upon c2, then what sort of line is this? You can take 1 minute in order to answer this. Is it a case of parallel lines or coincident lines? So this is a case of coincident lines, right? So we can have infinitely many solutions. If we are stating infinitely, that means it is understood that we will be having multiple solutions, right? The solutions are infinitely many. So these are coincident lines, fine? And this particular set is known to be consistent. While inconsistency is, suppose if a1 upon a2 equals b1 upon b2, but it does not equal c1 upon c2, then this is the case of parallel lines. And in this case, we have no solutions, right? This particular thing is known as inconsistent. So just by checking the condition, you can identify whether something is consistent or inconsistent. Now in next part number 2, when I'll be explaining cross multiplication method, I'll be also focusing light on how we can have multiple solutions analyzed using elimination method or substitution method, in case if it is feasible, or if it is not feasible, what best we can come up with. All right. So meanwhile, we conclude the session. Thank you so much for your valuable time, people. Thank you so much for watching the entire video. And if you are new to the channel, please subscribe channel. We are learners. You will get updates, right? Please press the bell icon so that you will be, getting regular updates. I'll be posting regular videos based on multiple topics, right? That are very much helpful in terms of power revision as well as in terms of competitive exam preparations. Fine. Bye-bye.